Hi, my name is Corey Petty. I work for Status, and today I'm going to talk about Waku, trying to explain how you can enable a new dimension into your dApps or subnet or what have you. We're going to talk a lot about what ephemeral messaging is, how we build it, and how to use it. So, next slide. I have this. So, what's a dApp? I want to start by talking about the concept of a dApp and how we currently build them, and our vision of how they should be built. Decentralized apps, generally, when you think about them as a smart contract or a set of smart contracts that work together, and some front end to access them so that they're user friendly. You need to be able to kind of craft transactions that get to a wallet and then you interact with, and MetaMask or the Objects Web Wallet or something. But it's missing quite a few things. There's a lot of other things you need to take into account, like how do your users interact with each other? Where is this front end stored? How does the wallet communicate with the front end? You have to use MetaMask, so you need a browser extension. Where does that information stored? How do wallets talk to each other? Things like that. And what we're trying to do is build infrastructure that is more aligned with the ideals we have of building a blockchain, which is this concept of decentralization and personal ownership and censorship resistance. And funny enough, in the process of building blockchains through all this time, we've just neglected everything else and used whatever's currently available to get the job done. Standard Web 2 technologies. So, with that in mind, what is Waku? Waku was born from Whisper, which was the brainchild of Gavin Woods in the original Ethereum white paper. It is the decentralized, peer-to-peer, censorship-resistant, ephemeral messaging. So the goal was to bring give every node the ability to communicate with the same censorship resistance that the underlying blockchain was provided. It was pretty much abandoned because it wasn't scalable. It had quite a lot of bandwidth and power constraints associated with it. So we took it, updated it, made it scale, and added quite a few features. But it's not just like a protocol. We have a network that's launched. We host it, but we're going to host it. We host nodes that are equivalent to everyone else's nodes. It's private, peer-to-peer, centralized. It's blockchain agnostic. We try to view this thing as a public good. We don't really care who runs it, how they run it. You're not tied to a token. It's open in every sense of the word. We take contributions from anyone through GitHub, and we hope that it becomes a standard of how you do ephemeral messaging with all the technology we're building around Web3. And it runs everywhere. We try to make sure that one of the original problems with Whisper was that it was very heavy. So we were running Geth nodes on a mobile phone. And very quickly, we burnt up too many phones or used gigabytes of bandwidth and destroyed data plans. So we've tried to alter the underlying protocol such that it's useful in a myriad of contexts. And doesn't necessarily do that if you want to use it on a phone, or it can do that if you want to do more heavy messaging. So in order to understand a little more about how it works, I want to give you the idea of what a Waku message is. That's kind of the atomic part that you need to understand across the whole thing. The message is the one thing that gets passed around, and it has a few different things inside of it. The payload, which is the message content. Content topic, which is basically it's the topic. So it's what you're listening to, what you're publishing to. You have two different versions, clear or encrypted, so you can send things in the clear, or we have built-in encryption schemes for automatically giving you end-to-end encryption. And a timestamp, when this message was sent, it should be noted that currently the timestamp is not something you should rely upon for any type of hard production purposes. It's just kind of a general indicator of when this thing was sent. And now that you understand a little bit about the thing that gets passed around, it's important to understand how it gets passed around and why that's differentiated. The suite of protocols in Waku is the relay, which is exactly what it sounds like. It's a node that sits on the network and passes messages around. It is a gossip-based protocol in that messages are passed around, like everything you receive gets passed around to all of your peers until the network is saturated. And we have some ways in which we can optimize that so it's not a complete flood network and you have a bunch of redundancy or whatnot. We have a store, so people can receive messages when they're offline. So you don't always have to have something on the network in order to receive messages. We have a light push for lighter mobile clients or resource-restricted devices so that they can send messages to a heavier node and get an acknowledgement without having to carry the burden of being a relay node or store node. A filter is something that you would use to basically ask for a specific type of messages. So you can run a filter node that stores things on a given content topic and then answers questions when people ask them. When people ask them, we do use Bloom filters such that you're not giving away too much information about yourself when asking for a specific type of message. And that's parameterizable based on how much information you'd like to give away or the efficiency of the response. If you don't have this completely small Bloom filter, you get a ton of messages and it's not that efficient for you, right? Waku message, which I went over, we have a bunch of built-ins that help you with various types of encryption schemes on how you'd like to encrypt those messages before you send them. And then we have some future work that actually just got merged into stable, the Waku relay, RLN relay, which is a zero-knowledge method for doing anti-Sybil and spam protection. So we can punish spammers on the network without revealing who they are. All these things are in the specs. They're heavily documented. It's like I said, we want this to be a public good and open to everyone, so we try and be as diligent as possible about writing very detailed specifications on how they're supposed to work and what to expect of them. So, for sending, we have relay, which is a gossip sub, and light push, which is a push and acknowledgement. On the receiving side, we have a relay, which basically it sends and receives whatever it gets. It'll always have it on. A store, like I said, for managing all the offline messages and giving them to people who need them because they maybe are using a mobile phone, and the filter. And like I previously said, we have a bunch of different ways in which you can parameterize this so that it can fit on any type of device that you want, based on the type of messaging you need to be doing. This is generalized messaging, so that could be a simple chat. It could be a text aggregator. We'll get into some use cases here in a little bit, but a bunch of different ways to deploy that. Might not be able to see the purple part that says VPS, so a little more online uptime guarantees, and then clusters, so strong guarantees and SLAs on node being up. We have, this was a graphic, but I put a PDF, so it's not so pretty. We have multiple implementations currently, one written in Go, one written in Nim, which is a fun little language that is strongly typed and very efficient, and one in JS. So this kind of gives you the scope of the types of machines you'd be deploying this thing on. JS Waku being mostly towards the browser, usability, user-focused. You can run a node in your browser to do whatever you want. The Go Waku library is written in Go, obviously. It's a library for integrating into whatever you think. There's a lot of Go development. Avalanche is written in Go, and I don't see another client implementation anytime soon. So if you're using that for a lot of the things, then it's easier to use Go Waku. It works on both mobile and desktop. Currently, our status application uses this for chat. So we run a Waku node on the mobile phone. And it's native to both of these things. So in Waku is kind of the reference implementation written in Nim. It is a service node. It has all the functionality, both like development and stable stuff. So if you want to know how something is supposed to work, that's the best place to check. Nim is a very readable language. So if you're into looking at the code itself and not specifications, easy to get started with. Oh, I didn't take out the slides you're not supposed to see. Let's see. Here we go. So what we've created on top of Waku, which is the generalized protocol for messaging across all of Web3, we tried to make it a little more easily to start getting and using as fast as possible. So we've created a few SDKs that abstract some of the difficulty or decision making for specific types of use cases. So we have JS Waku, which is an easy way to get started in the browser, and then a myriad of SDKs here. Waku Connect, the poll SDK, which will enable your token holders to create and answer polls. So you can do polling off-chain without having to manage any type of on-chain stuff. The Vote SDK to enable token holders to vote for proposals without spending gas. If you think back to a lot of the early days in Ethereum, we did a lot of things using the blockchain incredibly inefficiently. If you look at like the first implementation of Gnosis Safe until recently, every single acknowledgement or confirmation from a multi-signature wallet was done on the chain, right? And so that's because we didn't have this concept of ephemeral messaging, of aggregating the types of signatures together and then doing one thing. We basically had to force ourselves to do it because fees got high, and then other chains adopted the same thing. And the Status Web SDK integrates status communities, which is something that we're coming out with this year. We can consider it the Discord for crypto, being able to do token gating into communities natively and not having to rely on bots. So all the messages associated with the communities application is going to be also built on Waku. And then all of these docs and guides and examples, which we're going to run through one here in a moment, can be found on the wakuconnect.dev. We actively push towards it. If you made one yourself, we would strongly encourage you to contribute to it so that we have a lot of different easy ways to get up and running with good messaging. So why would you use this? What are some ideas you would want to use decentralized messaging for? We have dApp to wallet communication. So we have Wallet Connect now. Wallet Connect Wallet Connect v2 actually runs on the Waku network. So when you negotiate your handshake for connecting to some dApp from your mobile phone or whatever wallet you like, that's actually making that negotiation through our network. You can do NFT marketplaces, generalized marketplaces. You have this open network that everyone has access to the same information, assuming they have the correct credentials to decrypt all these messages, right? If you were to look at a message running across the network, it's indiscernible from anything else. We've made sure that not only do you have end-to-end encrypted communication, but you also have obfuscation of sender and receiver. So you don't necessarily know who's talking to who or what they're talking about unless you'd like to reveal those things. State channels are a wonderful application for this type of thing because the signature schemes you would like to use for this stuff are already built in. Game mechanics communication, we hear a lot about GameFi. We hear a lot about all the different DeFi stuff. I mean, arguably the same thing, just with a fresh coat of paint. Layer 2 coordination, we're in talks with a lot of different Layer 2s in the Ethereum ecosystem for doing their coordinators using Waku. This is a wonderful way to help them figure out how to move from centralized coordinators going into a distributed set of coordinators because they have the network, they can plop one down, and the ability to pass messages across each other already exists in a myriad of different contexts simultaneously, whether it be aggregating would-be transactions from users or connecting to each other as aggregators to settle up. Let's see, signature exchange for multi-signature wallet. I mentioned that. We just recently put out a bounty, which was gobbled up in partnership with Gnosis Safe to use Waku 2 as the infrastructure for relaying these messages for confirmations on transactions. So instead of relying on Gnosis to run infrastructure that passes these messages around and deliver that service for you, you can use a decentralized message that doesn't require anybody to exist. So you just need the contracts and the network that exists in general to do the same thing in a safe way. And then, of course, we're status chat messages. Your users may want to chat to each other. You want to build a social app or a social component to your application. It's very easy to just get started and just have your users chat to each other with the level of anonymity that is appropriate for you, whether you have KYC and everyone knows everyone, or no one knows anyone and you have a troll box in your exchange, right? All these things are easily done. Some highlights from this past year. Specs and NimWaku reference client significantly increased in maturity. A lot of optimizations, a lot of growth, a lot of release schedules, etc. Waku V2 got into production with Waku Connect 2.0, so we were able to work with Waku Connect quite a bit in helping them decentralize from version 1 to version 2. Let's see, inception of Waku Connect to help developers get started easily. I know there's a kind of a name similarity there, but Waku is multi-client, so we'll be building more implementations of this because we want it to be in everything. And like for instance, Rust is becoming quite popular in building or throughout the entire ecosystem. We'll need a Rust-based version of this. Let's see, and all of our testing from version 1 to version 2 has been confirmed in terms of the scalability benefits of, so give you context, Whisper, we took that, made Waku version 1, which was basically made it palpable, made it usable in the context of chat, which had limited scalability in itself because it was based on the same thing. And then V2 was a complete rewrite of the entire protocol, which had theoretical scalability, which has been confirmed by all of our use of it so far. And VAC Research, our research division for VAC is the messaging team within Status. It's its own separate entity, building things not related to the S&T token or specific to Status uses. So we can have talks like this and get you to build something that has nothing to do with us. They got serious and released the RLN Relay Network, worked very heavily with the zero knowledge community to come up with a way to provide anti-Sybil mechanisms and censorship resistance while also maintaining privacy for messaging networks. Same thing here, VAC. We research peer-to-peer, private, censorship-resistant communication. We desperately aim to operate as a separate agnostic entity such that you don't have to rely on the direction of Status to think that your messaging platform is going to move in a direction you don't want it to. We've built this out to be a public good, and we want it to work generally for messaging, with Status being a client of those things. So as we have demands for how the chat application works or whatever infrastructure we build, it doesn't necessarily push them in too big of a direction. Let's see. Yeah, so we're building public goods for Ethereum wide ecosystem. Check more out at vac.dev. There's links to specs, Discord, whatever, all the things. So I'd like to walk through, as this is a workshop, I want to walk through a simple coding example of giving you the shortest toy description of how you would use Waku.js to start a chat app and get going. So if you could switch over to the GitHub page, and this is available now. I may be doing something stupid, but you can go get this and run it and participate. So starting off here, standard header for HTML type, we have setting up the name of the thing, and then you have your input for sending a message, and your button which says send message. We'll see how that works in a moment. So this is the HTML part. We'll go down to the script right here. So we want to demonstrate the usage of Waku in the browser. Can you go back up? I'm going to walk through this right there. Yeah, so which is a simple thing, toy example of getting JS Waku loaded into your browser and starting to use it to send messages on the network. No, thank you. So let's see here. Can you read it? No, can't read it down here. So use relay and the gossip sub protocol to send and receive messages. The recommended payload for these things, if you're using a production app, is going to be protobuf, but for the purposes of this, we'll use UTF-8 so you can actually read it. And then we'll, in order to use this, after we run through this, I'll open up 2 browser instances and I'll show you how it works. So, can you scroll down a little bit, please? There you go. Setting up some things, pulling in Waku.js, setting up our DOM elements. Let's see here. So every Waku message has a content topic that categorizes it. So this is basically the channel you're publishing to. There's a specification on how to define these things so that you're not running over someone else. Negotiation of the topic gives you all the context you need to figure out how to decrypt the payload. Let's see, the topic for this one is the relay demo 1 message UTF-8. Like I said, use protobuf if you're going to do anything production ready. I'm going to start the Waku node here with Waku create. We bootstrap it here just to connect to our status nodes. We have hard-coded nodes so that if you wanted to not run the node infrastructure yourself, you can rely on us, but they're certainly not necessary. Go down a little bit, please. Here we define a hook, the Waku node relay add observer, which is basically just going to sit on that content topic and listen for any messages that come through and then decrypt them. So if it gets a message that doesn't have a payload, and the protocol version 3, payloads are optional, so we have to check to make sure that there is a payload. If there isn't, throw it away. Go down a little bit. Let's see. We have a bunch of helper methods built into the software itself, so that you don't have to spend time trying to figure out how to decrypt these things, how to use various types of text, so on and so forth. That's all built in. So we have, let's see, where did I go? There you go. Waku message on 101. The text is a Waku message payload as UTF-8, so it already knows how to handle the underlying payload. So we now know how to receive message or listen to a contact topic, capture messages, and decrypt them in a manner that we can put on the screen. And then we sit there and we want to connect to the nodes, so we can use Waku node wait for remote peer. What that does is basically just catches, it searches the network for a peer to send messages. And we define the send message, which is what's going to happen when we click the button. Capture the thing. More helper methods here from UTF-8 string, and then encapsulate that payload into a Waku envelope, which is the entity that gets passed around the network. So it does all the encryption, keeps it in the clear. All these things are, parameterizable, configurable as you'd like them based on your application. And going down, send a message, right? Send it off. So if you can go over to the 2 browser instances, I'm hoping there's not a ton of messages here already. Good, no one's using it. So I was hoping no one's going to grab on and start putting a bunch of lewd comments because I can't do anything about it. So if you can type, thing, right? What? That's a good thing, right? Sure, if that's what you want. We have no ability to censor anything on the network. So any censorship that would need to be done by you. So that's one of those things that we try to offer is censorship resistance at the protocol layer. And so since we can't even differentiate between who's talking to whom or what they're talking about or where they're talking, it's very difficult to censor any messages. So if you were to download this, you could take it over because it's a toy example. But it's ephemeral. None of these things are stored anywhere, so refreshing the page will get rid of it. But if you type a message into Waku note into the left side, you'll see it pop up on the right. If any of you got this thing somehow or another, you'll see it pop up on yours. In fact, I can actually do it from my phone here. So I have it pulled up. Can you go ahead and type something on there and whatever you want? It's your world. That's it. So it doesn't show your messages. You can show your message if you want, but for the purpose of this demo, one here. I am not on the Wi-Fi currently. I have to download this thing. Give me a moment. I think we have plenty of time, so not too worried about it. Try and open this thing. Oh, cool. Can't open. Worked the other day. Oh, well. I was going to do it from my phone. Anyway, doesn't matter. You don't need to be on the same Wi-Fi. You don't need to be on the same mesh, nothing. It's as long as you can connect to a node, you can send messages. You can define those things if you'd like. It's not only the Waku network. These are differentiated networks. So if you wanted to build your own outside of the messages that are happening on the status chat, that's perfectly capable of doing that. So you don't have to worry about the burden of success somewhere else crippling your ability to message within your own application. So that's it. We can probably go back to the presentation. There might be 1 or 2 slides of wrapping up.
So everything about buffering would happen client side?
Yeah, so this is literally just bringing it in from JS. Everything it's run on a browser, an HTML file that's you download. Everything would be run in the browser for this particular instance, and you're running a Waku node in the background. Spin up, spin down very fast. What was?
What side of time when you say very fast?
You just saw it happen. On my crappy laptop, you can load this page and be chatting in a few seconds. The longest it takes is to connect to a peer, which was 1 second or so. Let's see. Can you go down to the next page or over here? So the resulting dApp connects users, enables interactions. There's no back end to these things. If we didn't have a Waku node, you just have to define a way for it to find peers within whatever network you have. You don't need to have a ton of infrastructure to enable messaging. Only JS and HTML, no extra packages, nothing. It's very lean, and it defines any type of messaging you can possibly think of. So try it today. Got a ton of examples. We want people to be using this stuff. It doesn't help us in any way. We just think messaging should be a lot better than it currently is. Thank you.
Can you talk a little bit about what the nodes do? How it's different from like a consensus? Can you talk a little bit about what the nodes do and how what they're doing is different from like a consensus type node, like an Avalanche node or an Ethereum node?
Yeah, if you look about what an Avalanche node is, they're running a gossip protocol. They have a canned, I forgot the name of the underlying library they use off the top of my head to gossip messages around. They have to gossip transactions. A lot of the way in which consensus works on Avalanche is gossip-based because it's a metastable statistical protocol. Ours is something similar, but there's no underlying consensus. It's just grab a message, pass it on. And it's built off of libp2p, which is the much better library of peer-to-peer networks using any type of underlying interconnect. And it passes messages around. That's it. And you have some ways of filtering how that message is passed based on maybe the level of privacy that you may want. So you could basically have more redundancy around the number of messages you get, such that it's even harder to figure out who's talking to who, right? Because say for instance, if I ask you for a message, I'm giving you some information about the types of things I'm interested in because I have to connect you somehow, so an IP. But you have no way of knowing if I'm asking the message or I'm relaying this thing. So that's kind of, you bring a bunch of nodes, they pass messages, and we found a way to provide better privacy and security around what those messages are for and who they're going to.
If you add information like that to your request or something, does that increase the difficulty that the nodes have? Like right now, they're super performant, they can run on mobile, but is there more work that they have to do in those cases, or how does that work?
So that's why we have the suite of protocols, as we can kind of use the types of things you want to do appropriate for your use case without being burdened by the entire thing, right? The original Whisper was we do it all. You don't have a choice. You don't get to make a light and efficient, maybe non-privacy preserving or less privacy preserving method. It was you do the whole entire thing. And so you have a lot of options on the way you pass messages, how much you store, how light nodes fit into these things if you want to use resource restricted devices, or just everyone relays everything. And you can also filter based on I only care about this topic content, right? So I'm not going to be burdened by the message passing of everything else, right? And that's what I meant by you can have these differentiated networks that maybe somewhat overlap with each other, so that if you think about from a Venn diagram perspective, only a portion of maybe your network is connected to the larger mesh, and messages can get through that, while the majority of your particular users are not burdened by all those messages. They don't want to be.
So what I'm curious about is serving the nodes behind Tor. Have you guys had any experience with that?
I'd have to talk to Oscar about his recent foray into, so Oscar is the head of VAC, or the lead developer of VAC, which is the messaging research part of Status. I know that we're interested in trying to provide infrastructure for a lot of the more private networks like Tor and Mix, like NIM, things like that. But I don't know the current status of where they're going. A lot of the research and development has been going towards the using zero knowledge in whatever way we can to provide more privacy and security to the networks without decreasing, like adding more security or anti-spam mechanisms without revealing who it is, things like that. So we're definitely doubling down or tripling down on zero knowledge technologies to see what type of interesting cryptography we can use to provide better guarantees around passing messages around.
Hi, I barely understand peer-to-peer communication and this type of thing. But if, for example, in Telegram, or on Twitter, if you want to find a user, you type the username. How you can do this on Waku that a normal person can?
So that's the type of thing you would have to. So we're working on better discovery mechanisms. So how the underlying network connects or finds nodes that it cares about quickly. Discovery v5 should be ready. I think it just recently got merged. But like, say for instance, if you take Status, right? So Status which is a chat app, or partially a chat app, on mobile phones and currently desktop. There is no concept of identity at the envelope layer. If you think about the thing that's passed around, that just gets passed around. But if you understand what you know, if you know what you need to listen to, you can then filter and find the things you want. So what we did for usernames within Status was leveraged ENS to define subdomains of ENS to find global usernames. And so you can build whatever identification or authentication you need on top of it and use the other relevant Web3 technologies to figure that out. And since it's all using the same type of signature schemes and peer-to-peer methodologies, like most everything's built on libp2p these days, then it's very easy to just use them appropriately as opposed to being kind of forced into one method.
Can you talk a little bit about the nodes? Who are they, and like what's the goal with them, and how is it? It seems like they're super light. I know that's like when I stopped.
It depends, right? I mean,
Yeah.
what do you mean by the nodes?
Like who's passing these messages around?
Everyone who decides they want to. So if you, like that node on the browser that I just did, that would ostensibly, if listening to the right things, would pass whatever messages it gets to the entire network. So it's you need to define how much information you'd like to push around based on the resources you have available to you, and they get passed around regardless of who's running it or where they're running it.
So theoretically, I can, inside of the dApp, trigger the creation of an instance so that there's not even an instance inside of the dApp?
Yes. I mean, that they're like parts of it need to be ephemeral, and that's part of like we've had to come up with this stuff basically because we tried to take Whisper and put it on cell phones, which are resource-restricted devices, not only from their computation and power, like they run out of their battery, but also network bandwidth and churn. So they swap different networks all the time, multiple times, depending on where you are, or they're offline for a long period of time, or they're plugged in and then they have some more power because they're on Wi-Fi or various networks, right? And so we've had to try and adapt the ideals of Whisper, which are wonderful, to something that's actually usable for the scenarios we find people like in reality.
So my question then would be, I mean, we started talking about this in DEF CON Prague, was really when the first conversations were happening. Which parts of it are not ephemeral now?
The store. So that part of the protocol is I mentioned a suite of protocols. One of them is like receiving. So the relay node just relays and doesn't keep. So you need to be online if all you're running is relay nodes. We had this concept of a mail server, which is a terrible name, that basically stored all messages for 30 days and then answered anyone who asked them for what they want based on a Bloom filter. So like, I need messages that have this particular pattern, and the mail server or node would just give you everything it had, and the client had to figure it out and sort through it. So the store part of the protocol, the suite of protocol, the store protocol is a way to do that mail server function better and solely towards that. So you can define the level of message history you'd like to keep and the kind of the way in which you answer people when they ask you things.
So my question then would be, can you spin up and shut down the store, and so that's also additionally then ephemeral, newer for the period, only for the period that you want to be running?
Yeah,
a
sure.
node?
So then think about in the context of communities. So if we're looking at it like we have this new cool Web3 Discord, and it's going to be built in such a way that the administrators of the community have full choices on how their community is run, and that extends to, do we even have message history? Do you need to be online? Who's providing the resources to relay these messages and for how long? So a message on this network may only last a day. And if you don't log in, you don't get that message. So on, things like that. So like, you have that ability to kind of spin up and spin down on things.
And that would be available to each individual user on this Discord instance, or only to the administrators?
Well, for communities, you have to have some level of administration. It's token-gated chat, right? So who defines those rules? That's going to be the administrators or who creates the community. We can't stop, once they create a community with a given set of rules, we can't stop them. We can't shut them down. So if a user doesn't like that, they get to make their own or leave. But that's how anything works in society. So once those rules are set or managed within a given community, then that's what it is. And
Really awesome to see the progress.
Thanks, man. We've
Really.
been working on it for
Good work,
a
man.
long time. Anything else? Thank you.